Now I have to follow that. So,
You a little more time.
so I'll try my best not to overwhelm some people and then underload some people. We're not going to be looking at any of the code. This will be more concepts because I understand there is a mixed audience here. So I'll try to start from the basics as well as cover some more confusing topic. The basic theme here is about digital workers. I'm sure you all have heard this basic theory that, okay, a lot of jobs are going to be changing and a lot of kind of things that people used to do will be handled by AI agents. So let's start from understanding what is AI. Let's start from there. So what is AI? This is probably preaching to the choir, but bottom line is there is still confusion. What is AI? There are confusions around, is it actually sentient? People think of it as I'm chatting to GPT and I'm conversing with somebody who knows a lot more than me. What is it? This is just basically just these two things, data and algorithm. Data that it has retained, it has understood the context, and algorithm that actually processes it. Fundamentally, that's all it is. There is no significant intelligence that is behind the scenes. This is just these two, right? Now, the examples are chatbots and recommendation systems, all kinds of standard things, right? Now, how did we get here? It all started with the traditional thinking of artificial neural network. About years ago, it has all started with understanding what is a neural network. Basically mimicking what a human neuron will do, right? Connecting two points means recording a piece of information. So that's the basics of it. Artificial neural network is the beginning of what we know today as AI. ANN is the first one, that is where the machine learning algorithms started to become more prevalent. Then from there came more computer vision, which is more commonly known as CNN. ANN was the first one, artificial neural network, then came the CNN, and then came the natural language processing. Most people know today as GPT, literally means general purpose transformer. Transformer was the next evolution of that journey. GPT had several versions before this, and when it became 3, then that's when it became really useful, and practically overnight it became a sensation. What we know today as generative AI is basically studying the roots belong in the transformer. From there, it has gone into furthermore, it is not just about trying to predict the next word. It has gone into reasoning. It has gone into a lot more up-to-date information. But basically, the back end of this thing is still in the transformer architecture. Now, we may have heard these two terms, agent and agentic AI, right? So we'll get it out of the way at the beginning itself so that there's a little bit of less confusion around these two points. What is the significant difference? It is AI agent is something that is doing something on your behalf, right? Agent is supposed to do something on your behalf. The only difference between these two is that the agentic AI has a little bit more decision-making, and more of adaptive reasoning. What does that even mean, right? Understanding environment. There is still industry divided on these terms and still evolving, but basically this is what many people think of, or at least the common consensus is about the agentic AI. And you will see why it becomes even murkier when we look at different kinds of AI agents. Even within the AI agent, there is a whole range of things. Everything starting from simple reflex agents to learning agents. So now it's always even more confusing. What does it even mean? Basically, a simple reflex agent is where you have programmed this and say, okay, this happens, then do this happens, do this effectively, but the agent is operating on its own, right? It's a programmatic condition, if then else scenario. It could be something that is generated by AI, it doesn't matter, but still, it is a reflex agent, right? The model-based is based on a state of predefined model. Okay, if it's the model is AX plus BY equal to C, that's the model of a line, right? That's how you create a line. It's the same thing. So you have a model that defines how your environment looks like. And this model is what it's actually using to determine what should be its next steps. So if all the things that this is predictive modeling, a lot of things are still using the same system, model-based reflexives. The rest of it is self-explanatory, but basic understanding is that this is what it is. All right, now we are in the era of generative AI, right? So this fundamental thing we need to understand is, how do we actually work with these AI agents? These AI agents require, we all know, something called prompts. So if we were to use prompts, how do we actually work with it? There are many newer models and newer approaches that are coming up about how to build prompts, but this is the basics of all of it, right? There are 10 items, but basically what you need to understand is define what the persona of this agent is supposed to be, and then be clear about what is the task and objective is supposed to perform. This is an example that I have given here. If you give additional information ranging from examples, samples, reference material, all of those things, your agent will be a lot more effective. Your prompting will yield far better results. Okay, that's the basics of it. Now we have covered all the key understanding about the basics. Our talk today is about ERP. I was surprised to hear recently that many people don't even know what an ERP is. So let me try to start refreshing from there. ERP is traditionally known mostly in manufacturing companies, but it is being used in pretty much every company. Every organization that you work with today, they have some ERP. ERP expansion is enterprise resource planning, effectively meant for planning any resource that an enterprise is using. It could be people, it could be materials, it could be different things. So ERP systems, most commonly people know SAP is an ERP system. Microsoft Dynamics is an ERP system. A lot of mid-market ERP systems, and there is also open source ERPs like Odoo, ERP Next, and many of them. So what is today? All these ERPs, at least the older legacy ones, are mostly reactive in the sense, an order is entered, then what do you do? That's what a typical ERP would operate. Once the order is entered, it has to go to this place, this has to go to materials, buy the materials, make the materials, sell the material, whatever. But people need a lot more than that. Nowadays, you're looking at predictive. Okay, you've been in business for some time, so you know January, the demand will look like this. February, you will look like this. December, you want to look like this. It's basic predictive modeling on your demand. That can be done in an ERP. People want these kind of features. It's not just a data entry system. It is a basic predictive algorithm. Many of the ERPs has predictive algorithms built in, but nowhere even close to what the typical AI-based algorithms will be able to provide. And so why are we doing this? Because everybody wants better data, better decision. Now, what is different about this whole thing, right? Now, in the new world, we have this AI and ERP, which will drive decisions based on APT. Basically means that analysis of pattern over time. So you try to understand, you have data that's coming in, your order that's entered, your workflows. So if order entered, what do you do next? When do you procure material? How much inventory should you carry? All of those things are maintained based on workflows that you define within your ERP. Now you have to be able to learn. It's based on how much time it takes for a material to show up, or that's also changing. Today there is tariff, tomorrow there's no tariff. So now suppliers are wondering, should I send the material today or should I send the material tomorrow? Or I'm sure these are the things many organizations deal with this every day. Say, understanding historical patterns, understanding what might be happening in the industry, so to be able to react and learn along with it. Right? Think and adapt. That's what this literally means. Why do we even do this? Now, in addition to this, there is also sensors. For those who do not know, Internet of Things. So it effectively means that you have equipment that is able to provide you some information instead of human being. For example, let's say temperature. Okay, what is the temperature of a room? Or something like this, right? How much material do I still have it in my warehouse? I don't need somebody to go there and count it. You have cameras sitting over there. Everybody has cameras all around here, right? All they do is now record. Can these cameras actually detect the number of count of people? Can, based on this count of people, do something with it? or count of materials, do something with it. So those are the kind of Internet of Things or basic sensors that you are able to add. Okay. Now, what does this provide you? Real-time information, something that's coming from a sensor, real-time information, plus your ability to understand these patterns. Together, we are talking about something that fundamentally changes how organizations will go. You have this IoT and sensors and devices. Then your agents that are operating on these workflows more effectively. Then the ERP system which provides you the context. What is this customer are we talking about? Which vendor are we talking about? What is their environment? Where are they located? All of this context is available in your ERP. LLMs do not have any of this context. They only have whatever the model that was in. It's a AX plus BY equal to C. That's the model. It's something very similar as what you have in an LLM. Agent will be able to operate on that basic paradigm. Now, adding all these...
Question?
Sure, please.
I have a little bit of a background. I understand my friends. I went to universities and they go into all of this stuff. I also have experience in our industry. They go into all of this stuff. Now, a little bit getting into the run. It seems like a lot of this stuff is in here right now. So I understand that AI does it better, it does it faster, it does it cheaper when these things are put in.
All of the above. But what I'm explaining to you today is that with AI, AI agents, we are adding a missing piece. Traditionally, all these ERP systems expect human beings to operate on it. Okay, orders is entered. Now there is going into purchasing department who will make the procurement. Now, agent can do this procurement for you, right? Think about these kind of things, right? Now, we are talking about a combination of, this is an example of how you are able to automate something that requires a human to interface within the process stage of workflow to be handled by an agent. Add these three things together, you have a winning combination of a business workflow, a functional thing that actually continuously improves it's a continuous feedback loop for your operations to effectively. Does that answer your question?
Yes, it does. And quite honestly, I haven't been at a few department stores as a consultant on the virus, but still probably want to eyeball.
Sure. That's a good point. Actually, many of these scenarios, implementations is not the limitation of technology. It's more about people, their willingness to change, their willingness to adapt to new way of doing things, or importantly, letting go of control. Okay, I am responsible for buying $1 billion worth of goods here, right? What if that turns into I am now only responsible for $1 million and everything else will be handled by AI? Now suddenly my portfolio has come down, my value has come down. That's how people think about it. Unfortunately, that's the mindset is what is actually the bigger challenge. But some real cost saving, agility, and growth. That's very well explanatory. We are going to see cost savings and growth and with this kind of technology. There is some statistics that be publicly available that explains around how far you might be able to plug. You might be able to save 15 to 30%. Again, like any consultant would say, depends. And there are a lot of caveats and everything, but by and large, this is what we are driving towards. We should be able to get, at the very minimum, faster response time. That is the easily measurable number. Now, where do you see some of these changes? Don't worry about reading all these things. That's the reason I'm recording this is that will be available online. You're welcome to read it. But effectively, what we are trying to explain is that it is not just in one area. This will change all of the other areas. Finance, supply chain, customer service, HR. Nobody thought of HR, did you? So HR is about how many vacations days do I have left? Okay, you go to my HR, you go click on it, they go click to find out. What if a query can answer that question? Simplest things. All right, I need to go on a vacation on these dates, block my dates, or things like this can be far more effective if it's done by an agentic approach and you don't have to deal with clunky HR processes in unfortunately, many of the HR systems. The reason I picked on HR is because many people don't talk about what might be possible in HR. Customer service is pretty straightforward. Okay, you can chat with a customer service agent. You can replace that customer service agent, not replace, rather augment it. effectively you can say that portions of that, maybe investigation process of what discussions that happens can be handled by. So looking at that supply chain, we discussed that already, how we can think about how will it affect. So anyway, bottom line, finance is the simplest and easiest way, which is simple things like every company receives orders, every company receives invoices from their vendors. What if you could make it as simple as reading these invoices and processing them, right? If you could think about going through detecting policy violations, right? These are all the things that unnecessary waste an accountant's time. So you can easily take advantage of these kind of things. It's possible now with this kind of agent-based process. Okay. Now, what are the major hurdles in this? Right? Data quality. Everybody knows, there are those who have ever worked in ERP systems, how terrible there would be 10 definitions of one customer. One system defines the customer this way, this system defines this way, and that is why you have hundreds of consultants who are working on just fixing this data, and there are people who are re-entering this data from here into this data from here. All that kind of things happen. Data is messy. So what if agent could potentially help in cleaning, at least harmonizing this data, or maybe even advising, hey, this system has already defined this customer this way. Is this the same customer? Fine, a simpler validation. It helps you. Traditionally, these are all silos. Now, these silos can be harmonized with an agent that is operating. You can limit the agent's ability to certain data. There is a lot of safeguards you can place. You heard about MCP servers before. What if you could use those MCP servers to apply these safeguards and provide the specific data that you need for that work? Pick up that as an example. Effectively, what we're talking about, data quality and security. Yes, this technology will bring in a whole bunch of new security concerns. Increases the surface area, increases the potential for abuse, all of these things. So we do need to have some mechanism to deal with these kind of challenges as well. Above all, change management. This involves changing processes. Any automation, there would be impacts in the number of people that you're operating. Maybe there is a shift in how it approaches, right? Basic change management philosophy would apply here. And this is very clear there would be impact on this. So change management, I cannot stress you enough. Now, that's more of at a conceptual level. Now, for those who are interested in basically tools, so let's talk about some of the tools that we have today. You learned about the Surface AI Foundry, that's clearly within the Microsoft world, that actually Azure Foundry is a very good tool. But effectively, we're talking about the core sets. And you have, in the general sense right now, today is a lot of things are not just from Microsoft. There is enough from Meta. There is enough from Google. All of these technologies are available. Effectively, the LangChain, that whole stack was open source. A lot of these things that you will see is an open source, including what's available in Microsoft stack. So this box, I put it around the Microsoft stack. Semantic kernel is questionable now. I don't know what's the new story for that thing yet, but we'll see. The AutoGen, we'll cover a little bit on that today, but effectively, we are talking about the core. This box is Microsoft box. Everything else is everything around it. There's Langflow. Rasa, in case you don't know, this helps. Effectively, this is a set of tools, right? You're welcome to explore further. We won't go into a lot of details, but this is it. Now, we'll talk about AutoGen. That's one example of simple agent that you could actually build. AutoGen, it was originally built within Microsoft Research Lab, and then this guy decided to leave Microsoft and decided to join Google, and then Microsoft said he can take it with you, and they built further, and there's a bit of history behind that. Yes, there's a bit of that in the industry, but effectively, AutoGen is something that's available, and it's very effective in this approach. What does it actually do? We are talking about a different approach of how to build these agents. Imagine your objective is to create a children's story, right? So agent 1, write a kid story. Very simple prompt. Now the agent 2, you can tell them, hey, anytime there is a kid story, check for these things. There's no profanity. There's no blah, 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 certain criteria. Depending upon each state, it will vary. So effectively, you're talking about certain checks and balances. So you have agent 1 does something, agent 2 checks for something. That's precisely what in real life do, right? So then expanding that, we have conversational agents. There is few more. This thing has additional things. You can have multiple agents collaborating on potentially trying to come up with a reasonable solution. There is a whole orchestration layer that can help orchestrate these agents. Now, if you believe this is coding, you have a whole bunch of work involved in it, there is also low-code interface. Low-code interface will help you build something like this and then deploy it. On the right side, what you see here is an example of how it actually operates. So I want to look at the validate between Tesla and Meta. Well, yeah, Tesla and Meta stocks. Where do I invest? Simple question. Now, to do that, I'm going to need certain packages. So you're effectively telling your agent, go install the software. That's a big problem for people who are operating within IT, right? You cannot install software any way you like. And you don't know what you're dealing with, especially when you're talking about all the supply chain attacks and all kinds of other security vulnerability that comes in. Nobody knows where it's all going to lead. And where do I put some of those checks and balances? But do you have a choice? You have to stay ahead of the game, right? Now, this is an example of how far it can go, right? Simple example. Everybody is wondering, now that we know it is possible, where are we now and where does it look like? A simple exploration, multi-agent collaboration, this is what you saw a moment ago. That's where we are right now. Some may argue that the edge computing and IoT is already there. Why is it further down? The fact is, even when we talk about agent, when we're talking about IoT, so I bought myself a small microcontroller that can actually run a small model, if it's possible. But effectively, these are small devices. This is like an edge device. You connect into the USB, you'll start streaming data from the compute device here, something like this. This is an example of an IoT device. Now, what does it mean? Why is it moved away? Is because edge computing has not reached a level where you could run some of these small LLMs effectively within this microcontroller. That's probably why. But it's getting closer and closer. There is a lot of examples coming up. There is some practical functionality. The models are evolving and it's getting, right? That's when it reaches that kind of parity, you will see that, yes. It could be as simple as, okay, you have cameras. Your cameras, you are detecting an object. And then right now what it can do is create a notification, right? What if it can do more? Or simplest examples, things like this. Cameras is probably not a great example, but effectively you're talking about much more smaller devices, these sensors that you can even embed within human beings and able to understand, let's say, glucose levels and then do something with it or release a medicine accordingly or whatever. You see, the edge is there. Wherever the closest data is, that's edge. And from there to be able to compute and make decisions and implement something. That we have not reached there yet, but that's where we are talking about distributed intelligence. Intelligence is not, today the way it operates is you are sensing something, send this information back up somewhere, and then the process that is what to do with it comes from somewhere else, right? From the cloud or somewhere. So that's what we're talking about, the distribution of that intelligence. From there, it could go into intelligence ERP, or it may go into parallelly, I don't know. But the bottom line is things are changing. And so here is a rough idea of what the future outlook looks like. So what did we, to summarize, okay? We talked about today, AI agents and ERP, right? How they come together and potentially how it can actually change how we work, live, think, do stuff, whatever, right? Your everyday life. So this is what we're talking about. Together, it will become a next-gen ERP and next-gen solutions that will change how we live and operate. A few examples of some of the use case, ranging from predictive forecasting to inventory management, or even things like fraud detection and everything else that you see. So with that, I'll conclude here by simply saying that it's not a technology shift. This is almost like when Excel came into existence, right? Excel got released and everybody said, fine. It was there. We had Fortran before. We had Lotus 123 before that. So it's just a revolution of that. But Excel changed a lot of things for a lot of people, right? Suddenly, people can make a lot of calculations and make a lot of sheets that are personalized. That's where this thing is going. So if you're learning this, understand the evolution and get ahead of how you're actually going to be using for your function. Don't bother about learning AI details, inheritance. Learn about how you can apply it in your use case. You have a question?
So there's big forms like Salesforce, work data, actually get taken off. That's probably where they look at the ERP system. What the systems, owners, upgrade, and all of that. Can it be possible for the software development if ERP can lead like a Salesforce or I'd create your own bus software, and now your business.
Very good question. But let me ask you this. If you create a custom software, how many of you here who are developing custom software here today? 1, 2, 3. Okay. Now you would know something about technical debt, don't you? Now imagine quadrupling or rather exponential growth in the technical debt. The reason I mention that is because you are creating your own custom ERP. Great, AI will do it for you. But what happens after some time? What happens as it evolves? You will have to continue to build it, right? I'm using one example. Platforms like Salesforce or ERPs that you're talking about, they're not going anywhere. And I'll tell you my reasoning for that. Number one is that people are already invested in this. These platforms will evolve to leverage the AI tools. That's what is practically going to happen. They will utilize AI to make certain functions more effectively. Let's say Salesforce. Salesforce is all about CRM, right? At least in the beginning, but now Salesforce is far more than CRM. At the core, you're talking about customer relationship management. Salesforce is going to use AI, is actually using AI with the agent process to make that customer relationship process more effective. ERPs are going to do exactly the same things. The same workflows that you're talking about will add it there. And a question.
How easy is it to try and say build an AI agent into SAP? Because SAP, I had contractual restrictions.
You're absolutely right. And there are some real cases. Something there was that about DIGO, SAP's case, that was about SAP became restrictive to not allow access into that. But I think they resolved it. But bottom line is, ERPs are also, first reaction will be, we're going to resist it. We're going to fight it. That's usually these bigger companies, they have the contractual muscle, they will try to exercise it. But over a period, people will try to find a ways around and means around it. So it's a chicken and egg problem. But effectively, ERPs are becoming, if you look at the trajectory of how ERPs have grown. Previously, ERP, you can only run in my box that I give you, install it and run it in that corner that's in there, right? Now, okay, you cannot run it there. You have to run everything within the cloud that I am providing it to you. And all these things now, people are saying, all ERPs are thinking about opening it up. At least now, pretty much every decent ERP has a REST API. API capabilities are there. It is just the next level, right? You are talking about next, all of these people are going to offer MCP capability. After this, you're talking about AI agents will actually be appropriate. That's the trajectory that I see how things will progress. Does that answer your question?
One of the things that I know everybody's talking about happens when things go wrong. So they're not, why would they go? Well, the English language, that I believe is one of the most, a mathematician would not build a machine running on the English language. Even though I have difficulty talking to my fortunately is very light. The communication breaks down continually. So when you build a system built on large language and ask it to make a decision, one thing, you know a little bit about our stuff. You don't have an exposed value system. So when your system is balancing pros and cons and conflicting problems, do I solve it now or later? Or one way or the other, somebody gets unhappy, this machine's overloaded. All of those things are being balanced on the neural push. You don't know how it's doing it, but it's doing it. The issue is, how do you audit that kind of a machine? And do all kinds of things, like train it on good data. But if you're using language, you don't know exactly why it's doing, what it's doing, where it's doing. So,
What we are treading on is the interpretation of whatever. For example, insurance scenario, you're talking about a language, a statement that explains this is your coverage. And then what is the definition and how does it interpret from a legal standpoint when you have to pay a claim, examples. Or I'm trying to, let's say, a drone that is trying to put a bomb in this place. There's a school here, there's a military facility here. These kind of ethical scenarios, right? We're talking about. And effectively, LLMs is just models. It doesn't have any of this other information. Right? Even in today's, this is people who are making those decisions. They'll say, should I do this or should I do this? What we saw in this previous example here, orchestration. You have multiple agents that are actually collaborating and trying to come up with a decision. Is this claim valid or not? And that is realistically what is possible, in my opinion. Right? Again, this is my opinion. Second is that, okay, when does things go wrong? What do you do in real world? Right? There would be audits. There is checks and balances. There would be, when you're talking about just within model, you literally have no control, no visibility. If you're within agents, you can do a little bit more.
we come at the world where we're building machines for war. We're looking at fully autonomous, self-organizing swarm. So you just send a swarm out. They know the policy. They know the value system. They know what they see. And they can self-organize who does it. Anybody wants to know why, you can look and see exactly why every influencing factor, how that impacts every other. Your edge devices, those are going to be measuring voltage or light or whatever. Trying to find that those devices have the ability to actually do things, then they lose value and talk to them.
Correct.
Agents there's going to be a variety of things. I always ask, your world of AI is which companies turn their full company management, executive level, over to their AI tool.
Belarus made one of their counselors with AI. So there are people who are willing to do
A lot of them, but none of it. No,
get rid of. They want to have potentially not corruptible. What the question? You wrote the prompts.
The question is, what is the value system put in there?
Yep.
Got exactly.
You ought to at least be able to say, what do I value versus the guy on the sport running your national road or your subtrading? What were they think?
Isn't the value system with a little bit of Reddit and a little bit of 4chan? Essentially, that's what the LLM.
I don't know. The whole the beauty of this is the multi-agent system, where you can start putting in audit agent or ethic agent or all of these little specialized. Right? If we put a little specialized, then you have a little more focused, or a little more accountable, and a little more measurable for what is your account. I think that maybe
English language.
English language.
Unless you put a number every.
But isn't that the predictive model? And
so you can look at it and say, what the value of this versus the value of wall.
So if those who do not know what we are talking about is English language, or the way any of these LLMs interpret us. First step is to convert that into embeddings. Your language text, you convert it in embeddings effectively is that number value that defines the word. But doesn't tell you the combinations of word in this way can be interpreted this way, and this way can be interpreted this way. And depending upon what context you're using it, lawyers are known for these type of things, right? The reason why they get paid so much is they try to create this kind of language. Bottom line is we are coming into the same thing. And here's the big reason why, even if you make a large library of prompts that will create systems the way you want it, the system you create will not be looking the same way the system the other person creates, right? That's the reason for that. It can say it's hallucination, no matter how much you define.
Yeah, and my example of that is that I've been IT programming API in the IT side, programming ERPs. The manufacturing side is active part. I'm there, which cause things, and it's another. It's like where you're coming from. And the other, my example is Microsoft Word. Well, soon English right now. Because with the limited dictionary, is that every company, every person has a little bit of a different vernacular that they use on there, and if they try to put every single one in there,
Right.
my opinion is I do believe that APIs we talked about, this is what you're playing when you're answering me on there.
Perfect. Did you have questions, sir?
Get sick. Doesn't you still have your roles around board?
Yeah.
Man, they'll ask you all, or I'm serious. Change management, you have to roll through things, checks and balances to how the AI agents, generative AI, how it's change management, incorporate that.
There is a bit of that, but change management is more of a framework that takes care of technology, people, process. If you look at globally, there is a lot more. It already covers at a framework level. It may need some interpretation, a little bit here and there, but roughly as long as you're following a change management philosophy and the framework, the way that you would do it, only recommendation I would suggest is that follow some change management process, because this is not as if I will install a software and let it run. This doesn't work that way. You do need change management for functioning, implementing AI agents in any form of fashion. Did you have a question?
I guess. Before he knows more. Everything. We have our own coding. Again, without that we and carry and here. Whatever.
Here's how it suggests fixes after it looks out, which is a nice guidance. You're helping everybody follow the guidance with what you all the things that it's looking for. Remember, very different.
Programming workflow is going to have a significant shift. Everybody who is doing programming today, who's writing hands-on, right? They will find their workflow quite shifted today. This is, you're using pretty much everyone that I know is using some cursor or VS Code or any of those, or now products is starting to become available. But the workflow of how people build applications is changing. How you roll out these applications is also changing, which means the framework of how we used to do checks and of releases, that will also have to evolve. So simple things like, okay, what if we have script that will go and, let's say if I have to do a certain rate calculations, and then I have to do, instead of doing it, go to NPM or one of these PyPy or wherever to get whatever the latest code, and then that code brings in something that you do not want, right? Those kind of supply chain attack is becoming more and more prevalent. It's becoming, so this will just quadruple that kind of challenge. We just need to be aware of it and acknowledge those kind of things in our processes. That's what I would know. Any more questions? Yes.
Coming back a little bit more to the middle of the talk here. Still, you were talking about the ERP. Yeah. There. Do you have any real world examples of people you've worked with and what they're like that are actively doing something with it? Okay.
Yep.
And an ERP. Tell us a little bit about that.
Absolutely. So we have implemented a lot of these. We already explained few of the examples, like your documents that people receive, companies receive, invoices, sales orders and invoices, very basic things. People receive these invoices instead of trying to, We have bots or agents that actually reads these invoices, creates an invoice record, or reads these documents and create a sales order, or even responding to, we are actually in the middle of implementing some customer service agents. So this will reduce the way customer service receives a call about a product. Now they have to answer to that question, that query, right? Now that would involve asking, hey, have you tried this? Have you tried this? Have you tried this? This whole conversation could easily take from anywhere from 10 minutes to 30 minutes. What if an agent can actually do those steps one by one and do some diagnostics? Very basic, simplest examples. So this is where we are starting. But we know that there's far more. That these are the kind of some of the things that in real world we actually have implemented, right?
I've got another question for you. I'm just curious. So I know that you probably are talking to a lot of I'm just curious. The AI projects that you're putting in the company that you're talking to on there, what are the reasons that they're going to? Cost cutting? Is it something else on there? And are you finding any kind of similarity in the company that they service or the manufacturers?
So our focus primarily is small manufacturers. Small manufacturers, those who have some level of ERPs, and that's where we majority operate with. What do they want? We care more about what can it do. We don't get too much involved in those decisions about the kind of things that you articulated. But most of the things that we are concerned about is, can it improve productivity? Can it reduce for example, the customer service agent scenario that I've explained? Can it reduce the amount of time? Yes, did I answer your question?
Yeah, I understand that you were the consulting company would not make it just, but a lot of times, like I've been in your place on there and customer telling you, I need the money up in this environment. Maybe I can't know enough customer service.
Yep. Most of the cases, it's productivity improvement is what we most have seen. It is not about reducing headcount. We have not seen that kind of use case yet. Did you have a question?
My similar vein. They've got a manufacturer that had an ERP posing this type of an event system or environment. But there are ways for you to simulate that, to show them what type of improvements might be possible, or for you to give different heads of examples of this production line pulled down because of this breakage or something like that. And you know, the AI will respond. The book's duration for simulation.
We do have some of this, but you're talking about in the world of digital twin. Many of the small manufacturers, they're not ready for the concepts of digital twin yet, but we do have in a much more simpler scale, low-tech versions of what you're talking about. We have an ROI calculator on our site. That's maybe a good place to start. So there's a few more. If you need more additional information, I'm happy to explain, happy to discuss and understand the specific scenarios. We have a lot of use cases. We can build in we have enough data that's available to build those kind of use cases.
From like a maturity level or the total addressable market, a lot of people are doing stuff at very C1 or projects. What do you think, especially dealing with small manufacturers compared to much larger? Where do you think people are at in their life and not sure? A lot of people are gay.
You can go there and talking. We're your remote sprint.
So everybody's doing it. Have new sandbox. We are today, maybe like back in the 90s with either who's going to buy and they figure out all these other things. So more guardrails that are advancing up. Where do you think we are done with doing it, or how do you see it?
So it goes back to, you're asking this question right here. Where are we today? So in my world, what I see is that there's still a big continuum, but I see people are starting to use it. I have many people that I talk to, they all want to apply some sort of agent to do different things, mostly to improve the efficiency of the workflow of how they are operating. So and there is mess. I totally agree. And these technologies are evolving at a very fast pace too. And there is challenges. I'm not denying that. But if you don't, how do you get ahead of it? You start somewhere. Yeah, please.
Especially with small which in reality, right? Because we starting to implement, we call it your map. And at the end of the month, to look at it, I'm involved as well. It's unlike that because it won't, if it gets more and more consistent and more.
You're absolutely right. And that's why we have taken a completely different approach to this. See, I will augment what he said is effectively, instead of going to generating tokens or using tokens for everything, we are building one layer below that. So for example, we mentioned about embeddings. So use this embeddings to effectively getting technical details here, but of embeddings to get it faster, get it one level before we go into the LLM. We may use LLM, but that will be maybe the last level, or over a period, we will use less and less of LLM. That's the objectives in how the kind of system that we are building. To answer your question, today nobody's concerned. People are not worried about cost because the cost of tokens are only coming down. So there is the argument that, okay, over a period, maybe this will become almost zero. So why even bother? But I can see that optimizing it early on, which is far more effective, because at the anyway, and if this is not this, it will end up spending for compute or it will end up spending for something else. So best thing is that's how we are approached.
We say you overload it on that.
I can get into more technical details, but effectively this is all about embeddings caching. So you are trying to embeddings, we generate embeddings, we cache those embeddings and try to see the closest match. Can you get enough relevance with that set or not? That's what we do.
Peace. Consulting and not necessarily manufacturing, but been doing AI solutions for years. And the one thing I would tell you is that actually I have 2 points here. The first one is that the stuff that I did maybe 3 or 4 years ago that we released that was this expensive is now this expensive, and it's dramatically cheaper. I've got solutions out there that were cost prohibitive, that it was just too expensive to run. They're actually profitable, where give it a year and a half, and suddenly it was costing 1% of what it was costing to run the same thing. And at that point, all of a sudden the numbers turned upside down. Now it's profitable, now it's worth producing. So sometimes it's kind of things in the bank. The other point that I would make is that every project that we do right now, as we consult on things, once we get the thing built and working, and we usually chase expensive to begin with, one of our last steps is going through and figuring out, now what's the cheapest model we could use to apply here? And I call it the iron triangle of AI. It's balancing cost, speed, and quality. So those are the decisions you have to decide what the trade-offs are going to be between those 3 things. And oftentimes people think they need them to be the 99.99% accurate, but in reality, all they really need is or maybe 90%. And understanding what those requirements are, because standards, it's been going from 99.9% accurate to 90% accurate is traumatic. But it all depends on the particular problem that you're doing. The other thing we typically will do is decompose those big problems into smaller problems. And oftentimes it's only one small part that needs the really expensive model, and the rest of the problem can be done with something very cheap, or maybe even not AI, depending on your point.
So I will augment that, what he said was with, okay, the way you would approach that by, number one, so you could break down different parts, right? And maybe for every part, you don't need that level of accuracy. So what if you would use one part with a small language model to generate some response, so you can handle that tolerance level. So that is one way of approaching it. Second approach is to add distillation, or effectively we are talking about training a model that will do just this part of it more effectively. All of these things is to reduce the amount of compute usage, reduce the amount of token usage, and reduce the cost. That's probably how we would approach it.
Good point. And honestly, I was looking for distillation to be under 2023. Yeah, I think that's going to be perfect.
The way we have approached this is distillation is a process. Today, distillation is there, right? Maybe tomorrow will be something else, right? Effectively, what does it yield? That's what we try to. And so I trade away from keeping those.
Applying distillation, all that.
Distillation, RAG. Oh my gosh. Thanks. I was trying to get away from message. You may have heard these terms, RAG and distillation. They are two different methods to make your models more usable, more effective for that particular use case. RAG is retrieval augment generation. So that is meant for when you have a document that you want to, at the time after you generate, in the process states, it's probably coming at that last stage, right? You are adding this knowledge into that and then generating. That's retrieval augment generation. Distillation is very similar concept, but these models are distilled to, you're effectively having a larger model, train a smaller model for a specific purpose. So the classic example people generate is you use Llama 3 model to train a Roberta model, which is much model, for let's say feet analysis. Something very simple, but it will at that low cost performance, it can give maybe not 90% performance, maybe 80% performance. That's good enough in some scenarios. These kind of examples. So it's one is about augmenting from the content, the final level. The other one is more about training from a larger model to a smaller model for a very specific purpose. Is it?
Distillation is way cheaper, way faster, and can be almost as accurate as using a writing. And the idea is, the way I explain it to you, is imagine that a large language model tries to do about everything. So that's what it tries to do. Now imagine that problem space is a very tiny thing that I'm trying to do about our conditional. Why do I run that big brain that knows everything about everything? Why not just build any little brain that only knows how to solve that one? And that's what you're doing.
Or wouldn't that be, if you have a cluster of agents, you'd have an agent trained very specifically for that problem?
Correct.
You may remember from my screen. That was a point. So it's using, but I typically, that what's coming in the next year or so is going to be multi-agent, very small distilled models so that they run faster and cheaper.
You have a question?
Oh, I'm knowledge matter. I think of the graveyard of knowledge matter critical right there and looking at. And I've been hearing that they really have to find a way to ignore that. Knowledge, I think American Door thing just added those to the graveyard. So I wanted to know what techniques you have on building agents. Having no problem when knowledge is stored. When do you want large knowledge? When do you make decisions on how to structure the agent? That once your special tips, they're going to help. So not making the knowledge management because we're storing it.
The question really is that knowledge relevant for that function or not, right? So the classic example is that when ChatGPT 5 came, people didn't like it, right? Like there was a lot of people
like to hate them.
Like, why did that happen? Because generally it's supposed to be better, right? So more knowledge does not mean it's actually better. It is for that use case. It's a matter of tweaking. It's a constant process of tweaking. Maybe this emotional intelligence, I don't know, whatever they add in there. Bottom line is, these kind of, which knowledge is relevant? This is no different than you teaching a human being. Which knowledge is relevant? Is teaching how to do macros on Lotus 1, 2, 3 still relevant? I don't know. That's the kind of example that you're referring to. This knowledge graveyard, which is practically not relevant in the context. So maybe it's a matter of how you train it and when you train it and what knowledge is relevant. That's what we need to provide it to LLM. And most importantly, why is that relevant for which context, right? The general information is available already. The model is already trained on it, general public information. Some additional information that you want to augment, you augment for the specific purpose, not general. Let it read through all the documents that are available in a SharePoint and try to make sense. That doesn't work.
Well, but one quick thing. So I think this is really where tools actually help you. I would take all of your graveyard information, then come up with a query that basically says, let's go through all of this information. Let's do a deep research. Let's categorize it and then have the LLM ask you a question. I see the real this stuff is this important to the company. Isn't even relevant anymore. It's not relevant out there, but it's really great at processing giant with and stuff. And I would start helping it. Help you curate that data to be more relevant because you don't want to have bad. So that's where that's someone who would example that's where
Question.
So I'll throw on there too. So I've got a couple of these projects going right now, and I've quite a few in the past. This has been really popular in the last year or two. What made it really popular? You looked at popular Copilot and how it's been presented and how poorly it actually works. So that has made it a really common thing for us to get good up to do as a consultant project is please help navigate my SharePoint with AI. And so what we end up finding is that each time we do that project, what we figure out is how bad the data is. And we end up using the project to help them clean their data as we're doing it. So we start finding ways to identify the problems in the data, the stuff that's failed in SharePoint. We start helping them figure out those sorts of things and cleaning up that story. Because part of the reason that SharePoint is where documents go to die, it's everywhere. And nobody can find Xprint because 2,000 variants of the same document appears.
Use that to create media. One thing grew once a relevant document.
Mostly accidental, but yes. If there's a result of trying to build something like that, we'll typically end up putting together a pretty significant test cycle where they can validate that they're comfortable with the results and that they're willing to bring it to production. And at that point, that all the backend and the data come up through the service. And then we usually end up chasing. At least that's how it's been on average. I don't expect that to change based on all the SharePoints I've seen.
No. What is it doing here?
I think
It's a part.
that, in my opinion, that O365 Copilot fails so much is because it doesn't understand it. It's trying to be everything to everyone. And so it's kind of jack of all trades, master. When we go and build something for your business, we build that context of your business. And that's why the thing we built way better. Not because we're using dramatically better technique, but because we have the advantage. That will look a bit. Yes.
Is there any modeling and simulation with this so you can test it and then production?
Of course, that has to be in.
Yeah.
Yeah. So I would never release any of these things in production without having a bit of test. And even when you do, if you roll it out on a limited basis, long of your hair can love that very small subset of your beta. No way we roll them.
You do. So, yeah, and you actually had the Linesmith on one of your slides. So that's a tool that I use a lot. Hear that moving. Building out test stretch and then having AI going test on AI. It's great tooling for that. And there's some stuff that's popping up very Foundry, but starting to capabilities of and stuff. So that stuff's appearing in that platform as well. And a couple other platforms have spent. I would say it was the big thing this year that people were trying to figure out was, that hurt too much. It's
Cameron, how about we do in time?
yeah, we probably should. So yeah, I love you.
It's so much fun to talk.
Yes, I love the conversation. I'm still available afterwards, but I think we should have to wrap today's.
Yes, that's a good point. I didn't want to stop. Such great conversation. So what I would say is we do have the space for a while. Yeah. I'll feel free to have the restaurant, grab another sub, hang out and chat. Thank you all, and please sign up for next